Ya, Prof, mulai.
I will introduce the name of Bambang Guruh Irianto, the first author, Anita Miftahul, Maghfiroh, Muhammad Sofi, Yuni Kusmiati, Abdul Khalik, as a co-author who will present an article in the Telecomania journal with the title Telemedicine-Based Baby Incubator System with the DWT method to detect respiratory rate from the electrocardiogram signal. Next. Introduction. A baby incubator delivery is to use the warm newborn and is frequently used in preterm babies. It serves to maintain the warmth and humidity of the baby's body, can help avoid infant respiratory infection and keep neonates, especially premature babies, isolated. Premature infants are those that are born under usually circumstances with birth weights of less than 1,500 grams below average height, or gestational age of fewer than 37 weeks. Premature newborn required regular check on their physical health, including heart rate, lungs, skin, respiratory system, and digestive system, as these have not fully developed due to early birth. The research aimed to create a baby incubator equipment with a parameter baby monitoring system, including the baby temperature, ECG, and respiratory rate, obtained from the ECG signal obtained. Regular monitoring of the premature babies with vital sign is essential and is important to minimize the use of intrusive equipment to ensure they confirm. Facilities electrocardiogram, verified respiratory monitor, ECG, allow stimulation tracking of important parameters such as ECG signal and respiratory rate, while minimizing the number of devices installed. Next. State of the art. Moody et al. The ECG is effective by electrode placed on the body surface to monitor electrical activities in the heart, which is influenced by variation in the electrical impedance of the piston as the lung fill and empty. As a cure, the ventilation of the alveolus, the product of respiratory rate and tidal volume, which are regulated by the activity of central and peripheral chemoreceptor and pulmonary receptor. The respiratory rate is employed as one of the significant and marker of disease of the body system. It is clear from the data given above at effective and routine RR monitoring is necessary. Maghfiroh et al. Conducted EDR research and real-time from ECG lead to signal. The study used analog filter and discrete wavelet transform, or DWT method. Data captured in the age range of 20 until 30 at a frequency of 250 has researcher obtained the result that the use of analog filter without a mixture of digital filter still has a lot of noise. The result of the RR signal have no effect on ECG signal and noise. But in this method, there is a delay of 3 seconds and is a delay on DLP7. Sharma et al. The study found that utilizing homomorphic filter and discrete Fourier transform and discrete cosine transform approach, the RR signal from a single lead ECG is reduced in the frequency range of 0.2 until 0.8 Hz. The study used 3-band pass filter, Butterworth, JBC, JBFIS1, and PR FIR filter. The finding of then use the Kaiser windows from the extraction of RR indicate the order 50, and Butterworth filter produce superior filter result the JBFIS1 and PIR filter. Next. Method. The figure one show the block diagram of the module design is used in the system. The diagram is divided into 3 sections: input, process, and output. In the input section, the initial signal is captured from electrode placed on the respondent using ECG lead 2. After processing, ECG signal is converted into data by the Arduino microcontroller. Next. This figure transfer function digital filter. The process ECG signal is converted into the data by Arduino microcontroller. IIR filter are described using different equation, and the transfer function of the IIR filter is explained to in figure 2. The IIR filter is excellent and has a large processing capacity. And figure 3 block diagram of the wavelet transform decomposition process, or DWT method. Next. Data collect. The research begin is analyzed using offline data. This means that the data that has been collected will be processed and analyzed after data collection is complete, not directly while the data is being collected. The main goal of offline analysis is to understand the characteristic of respiratory signal on the ECG. They may involve identify specific pattern or parameter is breathing related signal with formula RR equals 60 to 5 T and plus 1 and minus T and N. Figure 4 SCG data collection using the ECG simulator, which is then used for offline EDR analysis. Next. Figure 5, the result of the ECG signal decomposition analysis using DWT. The respiration rate signal was obtained at the level 8 decomposition. In the figure 5, explain that the composition process was carrying out with the data taken for 30 seconds and respiratory rate signal was obtained in the composition aid with resulting decomposition frequency of 0.39 until 0.78 Hz. As the absolute mystic, the respiratory rate measured by the sensor and the respiratory rate computed by the suggested approach and compare. A t-test was used to assess the suggested method accuracy. Next. Figure 6 is an EDR system using the DWT method is real-time. Is the input ECG signal taken is real. B is the result of the composition of level 8 ECG signal using the DWT method, and C is comparison of the respiration rate of signal. Next. Result. And the state, the EDR process is carrying out in real time before it is first display on the personal computer monitor screen in the form of the ECG signal and respiratory rate signal as explained in figure 6 to ensure the composition of the signal information is spread into various frequency components, which can provide insight about signal characteristics. Furthermore, the data display on the baby incubator monitor display is in the form of an ECG signal and total respiratory rate value. In the context of ECG signal, it is to obtain respiratory signal from ECG signal using DWT with level 8, the composition and frequency rate of 0.39 until 0.79. Next. Figure 7, the ECG signal and respiratory rate value and display on the baby incubator monitor display. From what is showing in the figure 7, the results obtained were displayed on the big incubator display, baby incubator display in the form of ECG signal, heart rate, and respiratory rate value. Next, the test the performance of the EDR system. A test is carrying out the comparing result of the DWT method with the reading from the respiratory rate device to determine the accuracy of the DWT method before it is suitable for use for medical purpose. Next. Figure 8, Internet of Things approach for monitoring parameter babies. The microdata is processing into digital data, which is then sent by the resource PIE. A resource that data is sent via the internet to access the fiber-based cloud. And then from fiber-based data is downloaded from the Android system as explained in figure 8. Next, data transmission testing was carried out to ensure data no data loss occur, and the the data display was the same between the display on the baby incubator and the display on the Android layer. Next. This is the table to resolve. The table to resolve reading measure from the baby incubator display with no display. Next. Conclusion. The research aimed to developing a telemedicine baby-based baby incubator that can accurately monitor the electrical signal of the heart and respiratory rate of premature baby of premature baby using the DWT method from ECG signal. This research result so that the telemedicine-based incubator method has better accuracy in monitoring respiratory rate compared to conventional method which p-value more than higher 0.05. This study also showed the effectiveness of the DWT technique in detecting change in respiratory rate in premature babies. In it indicate that there is noteworthy this distinction between the two groups and that the error rate remain within the acceptable range for the therapeutic application. For future research, researchers will improve the quality of the ECG signal by using better electrode, develop a more efficiency and robust algorithm for extracting respiratory rate from the ECG signal and conduct more extensive and comprehensive clinic trials to evaluate the performance and benefits of the infant incubator system telemedicine. Thank you very much for